Hello everyone. Today I'm excited to walk you through this enterprise grade multimodal RAG system, a complete implementation that demonstrates advanced retrieval augmented generation architecture, optimized for large scale enterprise knowledge bases. Before we get into the functionality, let me walk you through the key capabilities of the system and then the complete technical stack that powers it. We have ensemble retrieval implementation. It demonstrates how we combine multiple retrieval types, BM25 sparse search, dense vector similarity, table extraction, image understanding, and knowledge graph reasoning. We use fusion techniques with metadata aware re-ranking to improve precision across heterogeneous multimodal data sources. We have a cross-modal feature pipeline. This handles feature extraction across different content types, processing text, images, and tabular data. It implements vision language models for image understanding, automated document layout analysis, and hierarchical chunking strategies for optimal embedding quality. We have a graph based reasoning demo, which that shows our Neo4j integration for complex relationship modeling and multi hop inference. This combines vector similarity with structured knowledge representations for enhanced contextual understanding. We have an observability and monitoring demo which showcases our complete stack of Prometheus for metrics collection, Grafana for visualization, Loki for log aggregation. We use a containerized ML architecture. It demonstrates our deployment setup with GPU acceleration support for model inference. We use a microservices pattern with dedicated vector database, search engine, and object storage. And yeah, we have implemented a modern ML API. We use Fast API for implementing RESTful APIs for ML model serving, and that also comes with Open API documentation, which is the industry standard for describing REST APIs. We can actually visit slash docs endpoint of our backend to see to interact with the Swagger UI and test out different endpoints. And this is the complete technical stack. We use Fast API for our backend framework. We use Grok for our LLM provider as it is fast and provides cost effective inference. We rely on transformers and clip vision for our multimodal embeddings. For databases and storage, we use Qdrant for high performance vector similarity search, Elasticsearch for BM25 sparse retrieval, Neo4j for graph based reasoning and relationships, Supabase for document metadata and PostgreSQL features, MinIO for S3 compatible object storage. For observability, we use Prometheus for metrics collection, Grafana for visualization, Loki for log aggregation. We use Docker for containerization, CUDA for GPU acceleration, and yeah, this entire front end is built by through React plus TypeScript. So let's dive into the actual RAG itself. So on the left hand side, we have the document management or the document processing pipeline. So over here, we can select our document processors. So what is this exactly? So we can actually select what part of the documents we want to actually process, whether we want to process the text in our document, or if there are any tables, if there are any images, or if you want to build a knowledge graph too for advanced reasoning. You just select these and then select whichever one you want and upload the documents, and it processes all all that things we selected over here, all the different parts of the document that we selected. We have already uploaded a document for this demo video. It's the same document that we used for the metrics collection part. You can check it out in the metrics tab under document ingestion. That's the document we are using for this demo video. So yeah, on our right hand side, we have the actual chatting part with our RAG assistant, and we can select different retrievers for all of them. Like how in document processors, we select which data we want to capture. In retrievers, we can also select which content type we want to retrieve, where we can most likely have our relevant documents in. Uh, so yeah, we can also select all of them. We have an advanced re-ranking algorithm that will re-rank all the relevant documents retrieved by each of these retrievers, find the most relevant ones among them, and pass it on as context for the answer generation process. So yeah, if, for example, if you know that your answer lies in the text content of the documents, you can just select text and BM25 and select tables and images. And if you're sure that there's not any complex relationships that require logical understanding, then also unselect knowledge graph. Or if you have some information that that you know lies in images, you can just unselect all these and just select images. Maybe there's some logical understanding and reasoning that's needed. You can also select this. Or yeah, you can just select all of them. The retrieval time is quite fast anyways. So yeah, let's try out a few examples. So here is the answer for that particular question, and here you can also see which top sources were used to come up with this answer. Now these are all the text chunks, all the chunks which are text chunks. Here there's also an image. Because you selected image as a retriever, it also found if there's any relevant image to this particular question and also use that as a source. Let's try another question. Yep, you can see this. Okay, for this you only found three sources that are actually relevant, uh, three text chunks. What if we ask something straight from the images and unselect this? Right, so it even fetches that particular relevant data from images. And in sources you can see the actual image itself. Yep. So let's dive into the metrics of our multimodal RAG system. So our this is the relevance scores by retrievers. Our sparse retriever has the highest relevance scores. And when it comes to speed, the sparse retriever has a 113 millisecond response time, average response time. Dense retriever has an average response time of 10.8 milliseconds, and the image retriever has an average response time of 51.2 milliseconds. If we compare different models for different content types, we compared five different text models: E5 base V2, GTE base, GTE large, E5 large V2, multilingual E5 large. So amongst these, the fastest was the E5 large V2 at 10.5 milliseconds. Of course, you can also switch to multilingual if you want multilingual support. That is also just at 12.7 milliseconds. And here are the three different vision models that we compared: Clip VIT L14, VIT B32, and SIGLIP. Amongst these, VIT L14 had the fastest image retrieval time and also the highest image relevance scores. To dive into the knowledge graph, these are the knowledge graph performance metrics, where graph traversal takes an average duration of 107 milliseconds. For query types, if it's by topics, it takes an average duration of 119 milliseconds. By section title, it is 223 milliseconds average duration, and by keyword, it is 670 milliseconds. To dive into the document ingestion, so yeah, here's the sample document that we use for our metrics collections. You can, of course, download it over here and check it out for yourself. It has 12 pages, 5 images, and 5 tables. So yeah, this is the average total ingestion time, 25.6 seconds that it took for this document. So in this time, to break it down, storage operations took 7 seconds, table image extractions took 6.64 seconds. Combined, it was a parallel process. Neo4j graph building took about 5.583 seconds. Vision processing took 2.8 seconds. Embedding generation took 1.3 seconds. And Elasticsearch indexing took 0.2 seconds. Qgraph vector search took 0.18 seconds. And text processing took 0.004 seconds. So the granular per item performance was So for each table, it took 1.38 seconds for the table extraction. For per image extraction, it took 19 seconds. Vision captioning per image took 571 milliseconds. For the text embedding, for average time took for per chunk was 80.6 milliseconds. Table embeddings for each table it took 28.2 milliseconds. For the average time for per image embedding took 83 milliseconds. Image upload, so average time it took per image was 688 milliseconds. It took about 193 milliseconds for database inserts and 9.4 milliseconds average per vector for vector storage. So we can access the Grafana dashboards through localhost 3001. This is how we can access the Grafana UI. We can dive into dashboards, and yeah, we have three different dashboards: document processing, HTTP request, and query answer generation metrics. The most important ones being document processing and query answer generation. Here we can actually see how much time it's taking for different documents, what's the average time for document ingestion, how much time it's taking by individual processes within the entire document ingestion process, like how much time it's taking for text embedding, image embedding, how much time it's taking for knowledge graph building. Same within query answer generation, you can see how much time it's taking for different queries, what how much time it's taking for different parts of the answer generation process, like time to first token by the model, uh, embedding and merge times, what are the individual retriever times, and how many chunks retrieved by retriever type, and how many query processed by status. So all these metrics can be visualized by through Grafana at localhost 3001. To summarize, this demo shows a complete end-to-end ML pipeline which supports multimodal document processing, uses text, image, and table embeddings, ensemble of sparse, dense, and graph methods, provides LLM-powered responses with citations. It provides a full observability stack, Grafana, Prometheus, Loki for log aggregation. This isn't just a demo, it's a reference architecture for building enterprise-grade multimodal RAG systems. The code is open source. Thanks for watching.